Hello guys, I'll be discussing the last question from today's weekly contest in this video. So let's start reading the question first and let's read it very carefully. So we have to find maximum elegance of a K-length subsequence. You are given 0 index 2D integer array items, okay, which have length n, and you are also given K. Every item has profit and a category, okay, profit and category. Let's define the elegance of subsequence of items as total profit plus distinct categories square. Okay. Total profit is sum of all profits. Means profit I, that thing. Okay. So you have to sum this and you have to find all distinct categories. Okay. All distinct category for all items in the subsequence. And what you have to do is you have to do like total profit plus rating subcategories square. Okay, your task is to find the maximum elegance from all subsequence of size k in atoms. Okay, there can be many subsequences possible of size k from the given items list, and then you have to find the maximum elegance out of all those subsequences. Okay, now a subsequence of an array is new array generated from original array by deleting some elements without changing the remaining elements relative order. Yeah. So here, will order matter? Like, will order really affect our answer? I'll say no. Why? Because order will not contribute to total profit and order will not contribute to distinct categories as well. So our answer will not be affected by order. So yeah, so my approach is greedy, and for that, the first thing I'll do, I'll sort the items. But before those things, okay, let's go through few more things. So let's look at the constants here. If that fits into it, yeah, I think 10 to 5 fits, like we can sort it, right? And then yeah, everywhere there are two. One is profit, one is category. Yeah. And then profit can range 10 to the power 9 and category can range till n means 10 to 5. Okay. Yeah. So let's again understand the question with this one. It will be easy to understand. Let's first understand the question with this example, and then we will understand the approach. Here, what I'll do is I'll find out all subsequences of length k. That is 2. One subsequence is 3, 5. And how many categories? Here, total profit. What will be total profit? 8, right? And distinct, what will be distinct categories? 2. Why? 3 belongs to category 2 and 5 belongs to category 1. So these two categories are not same. So there are two distinct categories. So what should be elegance of this? Elegance will be 8 plus 2 square. That means 8 plus and that is 12. Let's find another subsequence. Another subsequence possible is 3 and 10. Here, total profit. Let's copy this. So here, what would be total profit? 13. How many distinct categories are there? 2, again 2, 3 belongs to 2 and 10 belongs to 1. These two are distinct, 2 and 1. And elegance will be 13 plus 2 to the power. That means 17. Okay. Again, there is one subsequence that is still not explored, and that is 5 and 10. Let's find out here what would be total profit. It's 15. And how many categories will be there? Just one, because 5 also belong to 1, 10 also belong to 1. So just one category is explored, is used, and here the answer will be 16. That means elegance will be 16. Okay, but answer will be maximum of all these elegance, right? The maximum of the elegance possible for all these subsequent, that is 12, 17 and 16. So what would be the answer? Answer will be 17, right? So this is how you can understand the question. Now let's go to a board. Yeah, so let's look into this example. So this is a huge example, like it is having so many items, right? And these items I have sorted it in non-increasing order, like decreasing order, right? You can see. So, and on based upon what? On based upon profit. So here profit is 200, 180, 150 and all, right? And then there is category. And now what is K here? K is 5. And then what I have done is I have tried to make the categories. Like I have tried to list down all the items based on categories. So here in category 1, we have 200, we have 150, then 120, then 80, then 70. And here you can see that whenever we are traversing this list from left to right, since this is sorted, I have sorted it first. Because of it, whenever I am going from left to right, what I am seeing is in every category, I am seeing items decreasing in decreasing order. So even if we look for category 1, then all the items are in decreasing order, right? So the same thing I have done here. I am doing it. Okay. Since K is equal to 5, so the first thing what we can do is, okay, so according like, so this is what I am explaining. I am explaining my approach here, right? So the first default subsequence that we will take is all the items with maximum profits. So the first subsequence, the first default subsequence will be all the items with maximum profits. So these are all the items with maximum profits. This is in default. So this is the first case that we will consider, and we will find the elegance. So how many elegance, how much elegance it will be there? We can just sum it up, sum all of this, and then we can find the number of categories. So how many categories are there? 2 categories. And how many sum is there? Sum is just sum it all. What we can do is we can sum 200 plus 180 plus 130, right? So this is the sum. And then one more thing, distinct. How many distinct categories are there? So it's just 2, right? So this is what we will do. Okay. So this is the first subsequence that you can find. The next subsequence what you can choose here. So you can choose any subsequence of 5, but remember, I am using greedy here. So we will use some greedy approach to find the next subsequence. We will not explore all the subsequences. We will just explore all those subsequences which can give us elegance, which can be maximum, like which can give us maximum subsequence, maximum elegance, right? So we will just pick all those subsequences which have a probability to give maximum elegance, right? Which have like at least greater than zero probability. So there are few cases where it's just zero probability. If you will choose all these five, then it's just zero probability. So what we will consider is, let's take a look. So by greedy, we will take note of duplicates. So if we are considering this subsequence, these five items, like if we are considering a subsequence of these five items, then we will store all these duplicates, because here duplicate means like any element basis in a category which has already been used. Like one, like if this like for this item which is having profit of 150, so for this item 200 is already been considered. For this item 200 and 150 is already considered. So these two will be regarded as duplicates. Duplicate categories, not duplicate items, because items are anyway like different, but its category has already been used. So yeah, it's, we can either say used or like I'll say duplicates, so you can, since I have said it, so you can understand it. So 130 is duplicate here, since one item from its category has already been used. So I'll store all these duplicates, and this is one thing. And next thing is, there are categories which has not been used yet. So these are categories, category 3, category 4 and 5. These three are not been used, like still not been used. So how we can increase elegance? So either by increasing maximum profit, or either by increasing distinct categories. So here we have already used maximum profits. Since we have already used maximum profits, so now the only possibility where we can increase elegance is through increasing distinct categories. So here we have two distinct categories. Now we will use three distinct categories. So to use three distinct categories, either we can use 70, 40, 30, any of these, like any of these items, right? So any of these items we can choose to increase its distinct categories. So since we have two distinct categories, now we will have three distinct categories if we choose any of these items. But here again, we have to find some greedy method to not choose all of these. We have to choose like any of these in a greedy manner. So what I'll do is I'll choose the next item from all these which has maximum profit. So which has maximum profit out of this? We have 70, which is having maximum profit. And this is not coming from already used categories. So 70 is category 3 is not used, and 70 is the maximum profit that has been, that we can see. Okay. So the next subsequence that we can found which may have maximum elegance is, it it does not mean that definitely we will have maximum subsequence, but we will use 70. But to use 70, we have to remove some item as well, right? So which item we have to remove? We have to remove any item which is duplicate, right? So here, like all of these, like 200 will not be duplicate, because 200 will also be duplicate, but here we will not store 200. We will store only all those values which have lesser values, because if we remove 200, then it may not have maximum elegance, because it will not have maximum profit, right? So we will either remove 150 or 120. So in a greedy manner, we will remove out of 150, 120, 130, 180, all out of these, I'll remove the minimum of these five. So minimum of these five is 120. So I'll remove 120 from here, right? So greedily, I'll do two things. I'll I'll from not used, I'll from not used categories, I'll take minimum of these, and from duplicates, I'll use maximum of these. From not used categories, I'll take maximum of these, and I'll remove minimum of all the duplicates. So minimum is 200 and the maximum of not used categories is 70. So this is the new total profit, but new distinct category is 3 now because we have used 70 now. So the new subsequence is this one. This is the another subsequence. Like this is the first sequence, this is the another subsequence. Now the remaining duplicates are 150 and 130. 200 and 180 will not be considered duplicates because these are the first and which has maximum profit in each of these their categories. So for category 1 we have 200 which is maximum, so we will not consider it. We'll just consider 150 as duplicate and here 130 as duplicate. Okay, now going for next category, to include next category we can include out of these items, and we have to find the maximum profit item, like any item which has maximum profit. So we will choose 60. Okay, and here we will choose 60 because 60 is the maximum profit we can get out of these categories which have not been used, and we have to remove some duplicates. So I'll remove minus 130. Okay, so finally what we will have is we will have 200 plus. Okay, so the next, let's draw the next one as well. So next one will be till 60, and then you can see we are removing one duplicate, that is 130, and we are keeping all others, right, which are either maximum or not duplicates. So now we have 200 plus 60, and how many categories are there? Now category is 4. So we are one by one we are increasing categories, and we are choosing profits like accordingly. So yeah, to increase, so we are choosing items accordingly to increase our distinct categories, and so that our profits can also be as maximum as possible with those number of distinct categories. Okay, so now the next left category is this one. So this is the only category which has been left, which I have not used yet. So now out of these items, I have to choose any which has maximum profit. So I'll choose 45, and so I'll add 45, and I have to remove any duplicates. So now duplicates, the only duplicates which has been removed remaining is 150 only. So I'll just remove 150, and the new elegance will be 200. I have removed 150 and I have added 45, and the new distinct categories are 5. So now we have, okay, let's draw it as well. So maybe we can color it differently. No, I don't think we can color it differently. Yeah, so we have these many subsequences. This may have maximum elegance. So what we will do is we will find out elegance of all these, and we will return the maximum of all these 4, right? So that I'll not do here. So that you can understood now, right? So I can just calculate its some value. I calculate for it as well. For all these 4 I'll calculate, and I'll just return the maximum of these 4. So yeah, I think that you understood. But yeah, here we could have possibly made many other subsequences as well. I have not chosen them. I have avoided that those subsequences has been avoided to make sure that our code is optimal. Yeah. Okay, let's go for implementation. So how I have implemented this. Yeah. First thing first, I have sorted items based on its profit. So anyway, the first item is profit, so it will sorted according to profit in a decreasing manner. So it non-decreasing, right? So that's why. And then I have initialized a priority queue, and I have initialized a kind of vector which maps to categories. So we just find out which categories has been used or which have not been used, right? So how many times it has been used. So that thing it is keeping. And then okay, so we will be calculating elegance for the first default subsequence. So first default subsequence will be having the first key items having maximum profit. So anyway, we have sorted items in decreasing order. So the first key items will have maximum profit, right? So we are just going through first key items, and we are keeping duplicates. So to find out duplicates, what I am doing is I'm trying to see if the category has been used more than once, right? So if the category has been used more than once, then it is taken as duplicates, right? Not like items is duplicate. Again, I'm saying here category is duplicated. It here item is not has not been duplicated, right? So if category is duplicated, then I am keeping this in a priority queue, a minimum, a mini heap, or a priority queue, which whatever you can say. Okay, and then I am finding distinct categories. So to find distinct categories, what I'm doing is I am taking the size of subsequence, that is k, minus all the duplicates, right? And here it is the distinct categories. So the final elegance will be total profits plus distinct categories, a square, right? A square of distinct categories. So already I have calculated total profits, and I'm just adding distinct categories square. Okay. So I'll just initialize the answer as the default elegance that I have just found out. And then the next thing I'll do is, if there is no duplicates, I'll just return answer here only. Otherwise, I have to look for all other items which I have not used yet. So till k I have used. For the next items, which will be obviously lesser items than already used one, because items are sorted in decreasing order. So the lesser items now I am checking. So if let's read the comment here. Finding other categories which are not included in elegance and a stored maximum of them. Yeah. So yeah, what since I have shared you in the diagram as well, so we will be finding out maximum of not used categories. Okay, and then we have to find first occurrence, like for every item, like we have to find out if that item has been used first time. So or that has not been used earlier, and this has been used first time. Okay, so if that is occurring first time, like a category wise, so its category has not been used, then what I'll do is, then I'll just change the subsequence. Then I'll just consider for the next subsequence. So in the next subsequence, what we are having is our distinct categories has been increased by 1. So distinct categories increased by 1 a square minus the previous distinct categories. So the difference is 2 into distinct categories plus 1. So that I am increasing in the elegance. And the first line, like line number 37, you can understand that the item which has been included and item which I am excluding now, like from the duplicates, right? So this is the new item, this is the items which has been now excluded. And yeah, to find the answer, I have to just compare if this elegance is more or not. If this elegance value is greater, then I'll just update the answer, right? And the next thing is, I'm just removing that duplicate number since this duplicate has already been used. And I'm also finding if duplicates is empty, now I can return the answer. And the next thing is, yeah, basically I'm increasing distinct categories like one by one. So whenever a new category element is coming, there I am increasing distinct categories, right? And I am updating elegance for the new subsequence, right? This way, and I'm finding out answer. So I think uh, this helps. So let's submit it as well for your confidence. So this will be accepted. If you liked my explanation, please like the video. And if you are getting benefits from this, so please subscribe. It will help me. It will encourage me to do more of these kind of videos. And the next thing is, if you have any query or uh, you want to discuss something out of it, then please write down in the comments. I'll be happy to answer those. Thanks a lot.